Today we will continue our discussion from our previous video where we have ended with the condition that equation we have ended an equation with an equation. We are discussing the central force motion. Today we will discuss the first integral of motion. In our last video, I have discussed the central force. What is central force? Introduction to central force, and the equation of motion under central force. So we have got lastly this equation that for motion of central force. I'm doing a quick recap. We have got for motion of central force, under the motion of central force, what will be the Lagrangian? Lagrangian will be half m r dot square plus r square theta dot square. Let me write clearly. We have got the Lagrangian half m r dot square plus r square theta dot square, remember, minus v of r. Potential energy is v of r. This Lagrangian we have got for particle under the central force motion. So from the Lagrangian we can see here r dot is present, r is present, theta dot is present, but theta is absent. So we can call that theta is cyclic coordinate. Yeah, theta is cyclic coordinate means corresponding generalized momentum p theta equals del L by del L theta dot, from where we are getting mr square theta dot. Now we will continue our discussion regarding that. So we have got this, that p theta that is generalized momentum corresponding to the cyclic coordinate theta. Theta is cyclic coordinate because the time dependent part of theta is present there, generalized coordinate theta is present there, theta dot, but theta itself is not present. Now we will discuss the equation of motion. So for any Lagrangian, what is the equation of motion? We know ddt of del L by del q k dot. Here what is the generalized coordinate? Theta dot. Dt of del L by del theta dot minus del L by del theta equals 0. It is del L by del theta dot. What we have got just before previous slide, we have got del L by del theta dot equals what? Mr square theta dot we have got. So putting it into the equation, and another thing, theta is cyclic coordinate means no dependence of theta. So this part will be what? This part will be 0. This part will be 0 means we can write here ddt of m r square theta dot equals 0. m r square theta dot is 0. So we can write m r square theta dot, that means what? Is constant. That means sorry, m r square theta dot is constant quantity because time dependent part of that m r square theta dot is 0. So m r square theta dot is itself constant quantity. So we can denote the constant quantity by a physical observable. M r square theta dot equals constant equals j. Say this is j. So this m r square theta dot equals j. This is known as first integral of motion. First integral of motion. Remember this, it is very much important because we are getting under the central force of motion, that the first integral of motion is actually what? J is what actually? J is what here? Constant magnitude of, it is a magnitude of angular momentum. And what is that? That is constant, that is conserved because m is constant. So by manipulating it, we can write a thing here. So what we have got from the equation of motion, ddt of mr square theta dot equals 0. Now here one thing you know, m is what? M is constant quantity. M is constant quantity, you know. So here we can just manipulate this thing, because we have to derive a very important thing that will come in my next step. We can manipulate this equation as m is constant, so we can take any constant term there, because time dependent of constant term is what? Time dependent of constant term is always 0, and m is their constant. So we can write, we can, by manipulating the calculation, we can write any constant term is there. So what we will do, we'll put there in replace of m and half quantity. I will tell you why I am taking this half quantity. So we can write immediately there dt of r half r square theta dot is 0. From that, half r square theta dot, that is equals, what can we say? That is constant. Constant, we can denote it by h. So why I have put half here? Because this half r square theta dot is denoting what? This half r square theta dot is denoting aerial velocity. It's very much crucial term. This half r square theta dot is denoting aerial velocity. Aerial velocity is what? Now I'm coming to the definition of aerial velocity. Why I'm taking this? Yesterday I have drawn a picture in my previous video, that here we have taken a radius vector r, and here it is a point P at some distance P prime. Here we are taking another radial vector, and here small angle is d theta. D theta small angle is there, and here this thing is r d theta. R d theta. Here it is r. Here it is r d theta. So from here we can see what we can tell. This is a triangle, na? If I name this as O, so, and here O prime. This O prime P. This is a triangle, and this is what? This is r, and this is r d theta. So half into base into height. We can write here what? Half r square d theta also. What amount of, so what is, so radial vector is swapping what amount of area? This triangular is given half r square d theta. Half into base into height is the actual area of the triangle. So half r square d theta. So we will discuss this in such a way from this figure. So we can write the area swept by the radius vector, that is r is the radius vector here. Actually I am taking radius as vector here. Why? Because it has certain direction I have drawn in the figure. So we can write the area swept out by radius vector r is what? Let us consider small area element dA, that is what? Half into r square d theta. I have shown in the figure. So if per unit time, what will be the radius vector swept out? Per unit time, radius vector swept out will be dA by dt. dA equals half r square d theta I have got, and dA by dt equals half r square d theta by dt. So half r square theta dot, that is the aerial velocity we have got from the figure, and from the equation of motion we have got what? From the equation of motion we have got half r square theta dot equals constant. From the equation of motion we have got. So this is the thing. So this is the thing, that aerial velocity if constant, aerial velocity is constant. Aerial velocity is constant when the motion is taking place under the central force. So under central force, aerial velocity is constant. This is known as Kepler's secondary law of planetary motion. So we can write it here. Kepler's secondary law of planetary motion, not primary. This is Kepler's secondary law of planetary motion, that is aerial velocity. That, in other words, we can say that angular momentum is equivalent to say that the aerial velocity is constant. That's the thing we can write here. So now we can write another thing here. So that is a theta dependent generalized coordinate. So from there, another coordinate is what? Another coordinate is r, another generalized coordinate. So here we can write another thing. So there is another generalized coordinate, that is r. So if we take Lagrangian with respect to differentiation r, we take differentiation with respect to r of the Lagrangian, what we will get? Del L by del r dot, del by del r dot, we will get m into r dot under central force, and del L by del r we will get what? Del L by del r we will get mr theta dot square minus theta dot square minus del v by del r. So I'm writing clearly here. So from the equation of motion, if we take generalized coordinate r, what we will get? Del L by del r dot under central force minus del L by del r equals 0. So what this term will give? Del L by del r dot, it will give mr dot, because Lagrangian, what we have got? Lagrangian we have got in previous slide, half m into r dot square plus half m r square theta dot square minus v of r. V of r is the potential energy that possesses spherical symmetry. So this term will give mr dot, and del L by del r, this term will give mr theta dot square. You yourself, if you can do this differentiation, hope you all can do differentiation of the Lagrangian with respect to r and 1 r dot, you will get mr theta dot square minus del v by del r. Okay, so what we can write if we put this term here? We can write ddt of mr dot, we can write ddt of mr dot minus mr theta dot square plus del v by del r equals 0. Here I am erasing and writing clearly mr theta dot square minus plus del v by del r, because L equals 0. So here del v by del r we have got from central force, f of r equals minus del v by del r. From there we have got. So what it can be written? This term is what? This term can be written minus f of r, central force. So we can write corresponding to generalized coordinate r, we can write mr double dot means 2 times differentiating with respect to r, minus mr theta dot square equals f of r. We are getting this mr double dot. It's very crucial thing. Mr double dot minus mr theta dot square equals f of r. Now we have got what? We have got that j equals mr square theta dot, that is first integral of motion we have got. So from here we are getting the relation of theta dot. Theta dot equals what? Theta dot equals j by mr square. Theta dot equals j by mr square. Now put that equation. We have got the equation of motion corresponding to r, that mr double dot minus mr theta dot square equals f of r. Now put here theta dot's value. So you can write mr double dot minus mr. Theta dot value is what? J by mr square. So theta dot square is what? J square by m square r to the power 4 equals f of r. So m r cube we can write. So after clearing these, we can write in terms of that constant quantity, that angular momentum mr double dot minus j square by mr cube equals f of r. So this is a second order differential equation in terms of r coordinate. So we can write again mr double dot, I'm writing clearly, mr double dot equals j square by mr cube j square by mr cube minus del v by del r, Now it can be written in such a way by manipulation. After manipulating all the calculation, we can write directly that we will get at last the thing half m r dot square plus j square by 2m r square plus potential energy V, that is equal C, that is constant. Now this is the point of discussion here. So integrating the equation after manipulating all calculation, our main concern is to discuss about the result. What is the result we will get at last? So result we will get at last after all calculation. I am not discussing all calculation, that rigorous calculation. You will be all disappointed with that calculation. I know that is not so much interesting calculation, but the result is very much interesting. And what is that result? We will get half m r dot square, remember this result, half m r square theta dot square plus v of r, this potential energy, that is equal C, that is constant. It is another first integral of motion. Yes, this is another first integral of motion. Actually it is what? Actually if we write it by arranging properly, we can get half m r dot square plus r square theta dot square. It is what? Plus v of r equals E. It is what? This is a kinetic energy in plane polar coordinate. And v of r, this is a central force motion potential energy. So total energy T plus V is here present. This is another first integral of motion. This is the thing. So this is the another first integral of motion. So we got two first integral of motion. First integral of motion is what? J equals m r square theta dot. And another is what? Half m r dot square r square theta dot square plus v of r equals E. These are first integral. These two are the first integral of motion. This is very much important in our next discussion. Another important thing now I will discuss, that is differential equation of orbit. Differential equation of orbit. Differential equation of orbit we will discuss. So this is very much important thing, important discussion of differential equation of orbit. Let's start. So in case of central force, what is our main purpose? In our previous slides we have got what? We have got for central force, we have got first integral of motion, two form of first integral motion. But in case of central force we want to deduce what? Now we want to deduce equation of orbit. Whose solution can give us radial function r as a function of theta. Means when we will get the equation of orbit, the solution of this equation of orbit, we will get what? We will get radial distance r in as a function of theta. That's the main purpose of us. So as a function of theta, how we will get? So let's start the derivation. So for differential equation of orbit, we have got first thing, the for generalized coordinate mr double dot minus j square by mr cube equals f of r. We have got this. We have got this for equation of motion of particle of mass m moving under central force. Can be written this form also, mr double dot minus j square by mr cube equals fr. So our main concern is, how can we write the differential equation of orbit? I am not going total derivation. I am discussing the result. What is that will be very much important for solving any equation of orbit, differential equation of orbit. What is that? So differential equation of orbit has a form or can be written as d2u by d theta square plus u equals minus of m by j square u square f of 1 by u. Stop. I am stopping here. I am explaining all the term here. Okay. For your convenience, I am deriving the how we got the differential equation of orbit. So firstly, I have taken mr double dot minus j square by mr cube equals f of r. I am deriving because otherwise you will not understand how it is coming. So here it is one of the equation of motion under central force of a motion, central force if a particle is under the central force of motion of mass m. So r dot can be written as how? R dot can be written as, R dot means what? dr by dt. Dr by dt means how it can be written? Dr by dt can be written as dr by d theta into d theta by dt. Dr by d theta into d theta by dt, that means we can write dr by d theta into theta dot. Dr by d theta into theta dot. And now here one twist is coming. Theta dot equals what? From first integral of motion, first form we have got what? J equals mr square theta dot. So theta dot equals j by mr square. So r dot can be written as dr by d theta into j by mr square. So we can write r dot here, dr by d theta into j by mr square. Now in the equation we have got what? mr double dot minus j square by mr cube equals f of r. We have got this equation. So that means we have to derive r. Now we have to differentiate r dot once again with respect to time. So r double dot can be written as ddt of r dot. Ddt of r dot equals what? Ddt of j by mr square into not theta dot, I'm erasing it, j by mr square into dr by d theta. So ddt of j by mr square into dr by d theta. So it can be written that r double dot equals dd theta, that is ddt is outside the integral, so ddt can be written as dd theta into d theta by dt. So dd theta of j by mr square dr by d theta into d theta by dt. So now d theta by dt is what? Theta dot, that is j by mr square. So we can write here r double dot equals j by mr square dd theta of j by mr square dr by d theta. We can write in terms of here because theta dot again d theta by dt means what? Theta dot. And theta dot, what we have got? Theta dot equals, we have got j by mr square. Now we can, for our calculation, we can assume, suppose u equals 1 by r. U equals 1 by r, so we can write du by d theta. So we have got u equals 1 by r. So du by d theta, what we will got? We will get minus 1 by r square dr by d theta. So after putting all these things in the equation, we have got du by d theta also in the equation. Mr double dot minus j square by mr cube equals f of r. So r double dot, what we can write? R double dot, we can write that r double dot, we have got what? We have got r double dot equals minus j by mr square dd theta, j by mr square into dr by d theta. We have written these things. So r double dot equals, we can write from here, we have got that du by d theta equals what? We have got we have assumed u equals 1 by r, a constant quantity, and du by d theta equals what? Minus 1 by r square dr by d theta. So we can write here what? So we can write here, we can write r double dot equals minus j square u square by m d2 u by d theta square after putting all the terms. So we can write equation orbit as